This is AWR Microwave Office tutorial series. In this video, we will learn how to do yield analysis to understand what yield we'll get from different manufacturing tolerances and determine the best compromise for your design. In our case, it is an LR low pass filter. We'll just create the schematic from scratch and do the yield analysis. So let's get started. In the first step of this video, we are going to create a new schematic. To do that, we'll open AWR design environment, go to project window, and from here you have to create new schematic. Right click on circuit schematic and select new schematic button. We are going to name it yield analysis and click over create button. Next, we are going to place couple of components to create LR filter on this schematic canvas. To do that, we have to press Ctrl L on our keyboard. So the first component that we are going to place, and that is AC voltage source. So let's select ACVS. Click on OK. We'll place it somewhere here. Then we have to place resistor. So let's select the resistor. So one will be the source resistor, and we'll just Ctrl C and Ctrl V. And one will be the load resistor of this filter. Then again press Ctrl L. And next we have to place one inductor. So let's select inductor close form and we'll place it somewhere here. Alright. We can add ground on the resistor terminal, or you can directly add it on supply. In the next step, let's make all the connections. So all the components are sort of connected in series. Let's connect that. Now we are going to assign values. So before that, just click over zoom fit. So the magnitude in our case is 4 volt peak to peak. So that means we have to set the magnitude of 2 volt. The source resistance will be 50 ohm. Inductance will be 1 nanohenry. Let it be like that. And resistance will be 100 ohm. So this will be the V input. So as we did before, we are just going to place one marker, not marker, to be precise, it will be a rectangular block, so which will denote the source and the LR filter on this particular schematic. So let's draw that rectangle. So this will be the source. We'll add one text here. So this will be voltage source. Now before going further, I just wanted to show you the specification we wanted to achieve, or the goals we wanted to achieve from this yield analysis. So as you can see on your screen, we have this low pass filter. And if you'll see the first condition, so here we have 3 goals. So the first goal is the gain should be greater than -3 dB when the frequency is less than 15 kilohertz. Alright. So then we have the next goal. When our frequency is greater than 17 kilohertz, we want filter to reject that frequency. That means the gain should be less than -3 dB. Alright. And then we have another goal, the final goal. When we have frequency greater than 30 kilohertz, then we really want the gain should be lower than -6 dB. Alright. So these 3 goals we have to set. We'll understand how we can do that further in this video. So in the next step, we have to just change couple of parameters for setting up the frequencies. To do that, we'll just go to project option, double click here, go to global units, go to edit units. We want frequency in kilohertz, and apart from that, we want inductance in millihenry. So let's make it millihenry and click over OK and apply. So once we have set the global units, let's change this inductor value to 1 millihenry. And next we are going to add probes on input and output of this low pass filter. To do that, we'll just select the probes from this toolbar. Just place one probe at the input terminal, and this is the part of voltage source. So this is not considered as the input. Alright, so this will be the correct input of this low pass filter. And then we'll place another probe at the output terminal. Let's rename these probes to V in and V out. Now after adding the probes, we are going to create new graph and add measurements. To do that, we'll just select the graph, right click and click over new graph. First we are going to plot for gain. To do that, we'll just rename this LR gain. Make sure you've selected rectangular plot and click over create button. Once the plot window is open, now we are going to add new measurements. So in our case, as we already know, we have to measure the voltage gain. So first let's minimize this linear measurement type, go to non-linear one, and from here we'll select voltage, and then you have to select V gain. Now here you have to select the schematic. So in our case, we have only one schematic. So we'll just select the yield analysis, the name of the schematic. Then we have to select the voltage in components like we did before in the frequency response video. So we'll just click over these three dots, select the input probe and click over OK. Harmonics will be 1. We are not going to simulate for multiple harmonics. So we'll just select one harmonic here. Then we have to select the output component, which will be V out probe, and click over OK. And in this case also the harmonic will be 1. Make sure you have to select the magnitude in decibel and click over OK. Next we are going to set up the frequencies. To do that, we'll just go to project option, double click there, go to frequencies, and here we are going to simulate for the range of frequencies from 1 kHz to 100 kHz. So as of now it is in gigahertz, just change it to kilohertz. And then this will be 1, this will be 100. We are going to simulate this in logarithmic type. And number of points per decade will be 20. And click over apply. So here you can see we have 41 points between 1 to 100 kilohertz, and click over OK. Alright, now before running the simulation, I want to change the scale of this plot as well. So as of now, we have just changed the scale of the y-axis, which is the logarithmic. Let's make the x-axis logarithmic as well. To do that, we'll just go to options, and from here you have to make sure you've selected x here and click over log scale, apply and OK. Here we go. Now we are good to go for running the simulation. To do that, we'll just click over this analyze button. So I'm just going to place it somewhere here. You can minimize it as well if you want. So here we have the frequency in log scale, obviously, and here we have the gain in log scale and in decibel. Next, we are going to set up the marker at 3 dB point. To do that, we'll just add marker. We'll just add it randomly somewhere. Let's place this here. Then select this marker point, right click, go to marker search, and we want it at 3 dB in Y value, right? So we'll just press -3 and search. All right. So this is our -3 dB point, which is at 15.878 kilohertz. And yeah, so the pass band will be before that frequency, before 15.8 kilohertz, and after 15.8 kilohertz, there will be the reject band. All right. So as of now, we don't have any goals set here for yield analysis. To do that, we have to set the tolerances in our components on these LR components. Now to do that, we'll just double click over component, just select the yield, and here you have to enter the tolerances. So in our case, the inductor tolerance is 10% and click over OK, and register tolerance is 5%. All right. Next, we are going to set up the goals. So if we'll run the simulation, just after setting up the tolerances, we'll see no change in the simulation results. So we have to set up goals for yield simulation first, and those goals will be as per this plot, as you can see on your screen. So we have in total 3 goals which we need to set. So let's set the first goal. So we want our cutoff frequency to be between 15 to 17 kilohertz. And those are the 2 separate goals that we have to set up here. All right. And then third goal will be, we want the gain should be below -6 dB for the frequency greater than 30 kilohertz. All right. So let's set up our very first goal. Now to set up the goals, we'll just go to yield goals, right click, click over add yield goal, select the new and edit measurements. Now here you have to select the input and output component like we did for the gain plot. To do that, we'll just select here. This will be the input component. OK. Harmonics will be same, and this will be the output component. And in both cases, the harmonics will be 1. Now we are good to set up our goal for this first measurement setup that we did. So as per the plot, we want the gain should be greater than minus 3 dB for the frequencies lower than 15 kilohertz. So we'll select this measurement greater than goal, alright, and our goal should be minus 3 dB, and maximum on this we want 15 kilohertz, alright. So like below 15 kilohertz, the measured value should be greater than minus 3 dB. So that will be the pass band, if we'll say that in short, and then click over OK. So if we'll go to your LR gain, you can see we have set our first goal. When the frequency is less than 15 kilohertz, the gain will be greater than minus 3 dB. Alright. Next, we are going to set up another goal. And to do that, we'll just duplicate it. In this case, we are going to set up the measurement less than goal. And then we have to select the minimum and just make it 17 kilohertz. So it will be frequency greater than 17 kilohertz. The goal will be minus 3. Alright. So that means the gain will be less than minus 3 when the frequency is greater than 17 kilohertz. And click over OK. So here we have added another goal. You can see on this plot. Next, we'll just duplicate it again. So everything else will be same. Frequency will be greater than 30 kilohertz. And the goal will be minus 6 dB. And click over OK. Alright. So we've added our third goal as well. Next, we are going to simulate for yield analysis. To do that, we'll go to Simulate tab, go to Yield Analysis. In our case, see these 5,000 points, we can do that for 5,000 points as well, but let's reduce it to 1,000 points, 1,000 iterations. Now next, we are going to close the schematic. Now before closing the schematic, I want to add one more thing. So let's double click over these inductor and resistor. So let's select Use Statistics for both of the component and for resistor as well. Alright, then we are just going to close this schematic and make sure you have to divide the yield analysis in a vertical tile. So we'll just go to window and make it tile vertical. So we can clearly see what is happening exactly. And next we are going to click over the start button to start the analysis. And as you can see, the simulation has been started and we can clearly see after 1,000 iteration, how many percentage are falling between the goals we have set here and how many are outside the goals. So let's close this and we can clearly see the yield is 68.0 plus minus 3% out of these 1,001 iterations. So based on your requirement, you can simply go for pass and fail. All right. So 30% are outside that. Approximately 30% are outside that goals we have set. So this is how you can do the yield analysis for different type of circuits. We have tried that for a simple low pass filter, but these circuit can be more complicated and these yield analysis will be more valuable. So that's it for this video. Next, we are going to save the project. To do that, we'll just go to File, click over Save Project, go to Desktop. We are going to name it Yield Analysis. And enter. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.